Hi everyone. Today we are going to discuss about temperature sensors. And in the temperature sensor, we are going to discuss only the thermocouple in this video. So thermocouple is a temperature measuring device. It consisting of two dissimilar materials that contact each other at one junction. It also produces voltage when the temperature of one of the ends differs from the reference temperature at other parts of the circuit. And this is schematic of thermocouple where the measuring junction or hot junction. In this junction, two different dissimilar materials are fused together, joined together. And the other end, we have a reference junction. So based on the reference junction, we are measuring the temperature difference. And here, two wires of different metal alloys, and it used to convert thermal energy into electrical energy. It also requires a temperature difference between measuring junction and the reference junction. And it is very easy to use and easy to obtain the temperature difference compared with the remaining thermal sensors. And this is the actual schematic of thermocouple, how the thermocouple looks like. If you look at the schematic, the two different colors are shown in the diagram. So two different materials, two dissimilar materials are fused together. It acts as a thermocouple. And here we are using two different materials, copper and constant. And this thermocouple measures the temperature difference T1 and T2 between the two junctions. It is very easy to construct compared with other temperature sensors. You can just twist together two different materials and you can do a basic soldering process. And also best suited to measure temperature difference directly. And it also requires knowledge of temperature, that is reference temperature, to get the actual temperature T1. It works under different principles. It starts from Seebeck effect. In 1821, Seebeck observed the existence of electromotive force, that is EMF, at the junction of two dissimilar materials. It's actually the combined result of two other phenomena, that is Thomson effect as well as Peltier effects. What Peltier says is the temperature gradients along two conductors in a circuit that will generate an electromotive force, that is EMF. Whereas Thomson observed the existence of an EMF due to contact of two dissimilar materials at the junction temperature. All these three effects talks about when two dissimilar metals join together, the EMF generated. Pelton also discovered the temperature gradient along the conductors in a circuit to generate EMF, and Thomson effect is normally much smaller than the Peltier effect. And this thermocouple works under any one of these three effects. And this is the actual schematic and working principle of thermocouple. And we have two dissimilar materials and that is fused together, and we have two different junctions, measuring junction or hot junction and reference junction or cold junction. If the temperature of the both the junctions are same, then equal and opposite EMF will be generated at both the junctions. So the net current flowing through the junction will be equal to zero. On the other side, if the junctions are maintained different temperatures, then the EMF will not be become zero, and there will be net current flowing through the circuit. And the total EMF flowing through the circuit depends on the metals used within the circuit as well as the temperature of the two junctions. And this thermocouple used to measure the amount of EMF flowing through the circuit due to the two junctions of two dissimilar materials maintained at the different temperature. Those two junctions are, one is reference junction with a known temperature, another one is measuring junction with a unknown temperature. I hope you understand about thermocouple. Thank you.